Welcome to the Land Tamer stream this Sunday afternoon. We are about to do a couple of OSPF labs. I have been watching quite a few videos, and excellent videos, by the way. If you're not, hopefully you have by this time purchased some sort of workbook or instruction package from a vendor. There are multiple ones to select from. I happen to use INE and have to give a shout out to Brian McGann and his instructional videos. I have a lot longer way to go with OSPF, so a lot more learning for me, a lot more reading, a lot more instruction, and the first few videos are actually really good on OSPF. I'm kind of coming back to OSPF. It's been 2-3 years since I've really done much with it at all. So some great intro videos and really taking it to the next level because with OSPF, I'm trying to get, as with anything CCIE, any of the technologies covered, in what we're supposed to be learning, any of the technology areas. OSPF is one of those where I need to go deeper and I need to really understand the LSA types, the SPF algorithm, how OSPF is making the selections, area types, all it's good stuff. I'm glad to be back in it. Some of it at this, I will say right now, the external types and some of the more complicated parts of OSPF, some of that's going a little over my head right now because I just need to get grounded again in the basic algorithm and the configuration of it, design of it. So I'm looking forward to these labs. These are the simplest, I think. I mean, there's quite a few steps here in this one and in the other one, but I was getting to the point where my eyes were kind of glassing over once you watch so many videos and do so many reading of the docs, and it's time you got to kind of start to apply it. Got to start putting it into practice. And I was getting to that point. Plus, Sunday afternoon, I tried to take a nap, didn't work because I was thinking about streaming and learning. So we're just going to get into it. It may be a little rough, but here we go. So the first one is broadcast links. Using OSPF over broadcast links, very important in OSPF in understanding the different link types. It's link state, right? There are arguments about how to categorize OSPF, but it's definitely is very involved with the link state, the link types, and specifically what type of networks those links are connected to. So that's going to impact how we configure it, of course. And in this first lab, we're going to do broadcast links. Second will be over DMVPN, which is non-broadcast. So I'm probably going to be referencing, I have not read up on a lot of these commands, so I'm going to do a lot of that in this first lab. Even the show commands, there are a number of show commands that I really want to hone in on as well. But we will go ahead and do some configuration here. Let's look at our topology and the requirements. Before we touch any keys, let's look at what our requirements are. So router 6, 7, and 9, I happen to know those are all sort of in a sort of a logical area here, right? They're all in line, basically. So we got router 6, 7, and 9, and those are going to be in regular configuration, router OSPF 1. On router 9, it's asking us to do interface level commands alone. As we know with OSPF, you can, at least with IPv4, you can configure a lot through the router process itself, router OSPF 1, and underneath the router context, or the router configuration context. Or we can do strictly, or a lot of it strictly under the interface level commands. So it's going to mix those up a little bit. Then we're going to have two different areas, so that's going to be fun because we're going to get to see not just LSA types 1 and 2, but we're going to see at least LSA type 3s here, pretty sure. So router 6, 7, and router 7 and 9 are going to be in different areas. So it looks like, so 6 and 7 are in area 67, and 7 and 9 are in area 79. It doesn't say anything here about area 0, which I find interesting. Obviously, for there to be any sort of communication between, then we need to have an area 0. I find it interesting that we're doing multi-area here in this first lab, but we're gonna go for it. It's saying here router 6 is loopback 0. We're gonna advertise in area 67. Router 9s we're gonna advertise in area 79. Now I don't think area 0 is configured here already. I did have to load up new topology files. So I've already done all that work. Let me just look in the base topology. It's called initial OSPF. And I don't think it has any dynamic routing protocols configured at all. No. Okay, just checking to make sure. So obviously, I already know that these all have to be reachable, at least from router 7. So, okay, 6 and 7 are an area, and 7 and 9 are an area. Okay, that should be fine, I would think. Because it doesn't look like we're going to have... Okay, so the requirements are not to demonstrate communication between areas. So as long as router 7 can reach 6 and 9 loopbacks. Now, it will be running 2 different OSPF routing processes. So what we're going to do here is, let's see. On router 6, we're going to enable OSPF with these particular networks. I think it wants exactly these networks. And then that's the loopback 0, of course. And then router 7, we're going to enable OSPF on the subnets within these 2 networks. So in other words, it's saying we're going to be configuring and learning kind of the network statement, right? And how to use that correctly. It's not this lab, but I think the next one where it wants a particular router to have a single network statement. It's not saying that here. So we don't have to get too crazy with that, it looks like. All right. So this is going to be interesting. We're going to have, again, these are broadcast links, right? Because they're Ethernet segments, standard Ethernet. And then router 7 will be in 2 areas, and we're going to kind of see how that interoperates. So this is good. We're going to get to use a lot of different commands, and it's going to be my opportunity for the first time in a while to look these up in the Cisco docs and see what all the options are, and just, we're getting warmed up here on our OSPF. That's what we're doing. All right, so on router 6, 7, and 9, we'll do router OSPF 1, with the exception that 9 has to use the interface level commands. I think what I'll do here is the first part at least, I'm going to just write this out. So router 6, for example, we're just going to say config T router OSPF 1. And we will say here network. What are the networks? And it's funny how the order here, right? And this is the kind of tricksy stuff I can see them doing in the real lab, and this is real world too. People don't often give you requirements in a logical order. They're just kind of dumping. Oh, we need to do this, we need to do that, we need to do this, make it happen. So we're not going to necessarily process these requirements sequentially, right? So we're going to say, we're looking at router 6, and we know that he's going to be area 67, but what links? Because that's where we're going to define the areas as well. We have to enable it on 150.1.6.6, and router 6, I'm almost sure, is going to have... We have to be careful about our network statement here, because if we do show IP interface brief, we don't want to include any networks that are not part of the scope in OSPF. In any links, right? We have to think of links. So on this one, yeah, so we have two different links in the 155.1/16 network. So we're going to have to be pretty specific here. Same 150.1.6.6. So to enable those, we could, there's probably 10 different combinations of things we can use here. But I always think, it's great to be as specific as you can, because that way, if you're coming in here, someone new to the network, and you're just looking at the configuration, what's going to make the most sense? What's going to be the most specific, in other words, to identify the interface you're doing? I would say here we're going to do 150.1.6.6 and then 0.0.0.0. Because we want to look at that specific interface only. And then we're going to say area 67. Again, I'm doing this raw. I have not configured OSPF in a while, so hopefully that's right. Same here. I'm going to say network 155.1.67. I'm going to put a 0 here. Area. Now, it does not say which area to put this in, like it did for loopback 0. However, we do have to enable it here. Obviously, we're going to have communication with router 7. And this is going to also need to be 67, right? Okay. So I think that would be router 6. Now let's jump to router 9. Now in this one we're going to do, it says interface level only commands. And in router 9, we know we need to do loopback 0. And we can, we can derive the fact that we need to do this on the link between router 9 and router 7, because that is the link that they share. So that is going to be the interface, big T, interface GI0179. I got two. I don't normally type ER, but oh well. On this, we're going to say IP OSPF network. I'm unsure of how to do that. So we're going to look that up in a minute. Let's go ahead and do that now. Guys, I'm going to have to take like a 2-second break here. I'll be right back. Okay, we're back. So we're going to go ahead and look up these commands. Like I said, this is a revisit, right? We're getting reacquainted with OSPF. So what we want to do is, okay, everything looks good. So let's look up the command for the interface level. Actually, let's go to the config guide. I think I'm on there already. Yeah, configuration guide. Configuring OSPF. I don't know if I need to do this now. Interface parameters. Okay. So there's a lot we can put on here at the interface level. Pretty much most of the OSPF parameters that we want to use. That's NSSA. Enabling OSPF. It might show me here. It doesn't have the network command there. All right, so let's go to the command reference. If all else fails, do the command reference. All right. Master index. And that's going to be, I believe, IP OSPF. Yeah. IP OSPF network. Okay. So let's just kind of reacquaint ourselves here. To configure the OSPF network type, other than default for given medium, which the default is disabled, use the IP OSPF network command, configuration mode. And here's where we get into some of the options we have for the broadcast and non-broadcast, which we will be using coming up. I think particularly in the next one with DMVPN. But broadcast, set the network type to broadcast. Non-broadcast, set the network type to non-broadcast multi-access. And then we have a couple other modes here. So point to multi-point non-broadcast. Looks like we have 4 options total, right? Yeah, I remember this now from CCMB. It's starting to come back. Point to multi-point non-broadcast. So we will be using that in the next lab. That's a DMVPN. The optional non-broadcast keyword sets the point to multi-point network to be non-broadcast. If you use the non-broadcast keyword, the neighbor command is required, right? And I know when I was doing CCMP that we did a lot of this in the lab over a frame network. Yeah, GNS3 frame network configurations. That was a lot of fun. Since that is not part of, from what I understand, the version 5.1 written or lab, I think all that we do here is going to be with DMVPN networks to demonstrate this, which is good because that's more of what we're going to see in the real world these days. And then point to point. So we got broadcast, just to review, non-broadcast, point to point, point to multi-point, non-broadcast. It looks like you can use point to multi-point without the non-broadcast keyword. And you can do point to point. Now this is interesting. The command default depends on the network type. Using this feature, you can configure NBMA networks when, for example, routers do not support multicast addressing. You can also configure non-broadcast multi-access networks, frame relay, as well as broadcast networks. This feature saves you from needing to configure neighbors. Yeah, it talks about virtual circuits, which is, frame relay. For example, partially mesh network. In these cases, you configure OSPF network type as point to multi-point network. Routing between the two routers that are not directly connected will go through a router that is virtual circuits. Yes. Okay, if this issue is issued on an interface that does not allow it, the command will be ignored. OSPF has 2 features related to point to multi-point networks. Yeah, we talked about that, broadcast and non-broadcast. Okay. Now I'm assuming, this exercise, this lab, is for a broadcast network. I am assuming that is the default for a gigabit Ethernet interface, but we're going to verify that and make sure. So here's how you do it on interface, right? IP OSPF network, point to point. Okay. So we need to, there's still something we're missing on the command. Let's look at router 9. I'm going to need a little help with this. And the command line is going to come to my aid here. That is going to be interface GI0179. And if we do IP OSPF, okay, so process ID, yeah, that's what I was missing. So the process ID here is going to be 1 area, and this is going to be 79. Oh, I have to type the word area, 79. Okay. So that puts, this command will put this interface into area 79 for OSPF. It will run OSPF process identifier number 1. Okay. Include or exclude secondary IP address. The default is to include, from what I understand. So what are the other IP OSPF commands we can use here? Adjacency, the process ID, authentication. We're going to be doing that, I'm sure. BFD, cost. Database filter. I've never used that. Dead interval, demand circuit, flood reduction. Hey, if you have flooding, you got flood reduction here. Low interval LLS, message digest key, MTU. So basically, all that you can configure with OSPF, we can do it right here at the interface level. It does appear. So again, the command is IP OSPF, and then process ID. Now, how is that shown in the command reference? Is that just IP OSPF? I would assume so. Let me go to the previous. IP OSPF. Now, how can we see the usage? Where's the usage documented? That is, yeah, we're entering now the process ID, 1. So is that under P for process? No, we've got priority. I don't see a way to learn this. Yeah. So if we, basically we have to rely on the command line here. I'm sure this is in the config guide. I just wanted to see it in the command reference. So I have to type IP OSPF1 area 79, and then I should be able to hit carriage return here. What that's going to do is it's going to put whatever IP or network address that's configured on that interface automatically into OSPF, right? So the command, I had that wrong, is that. Okay. So router 9, it also wants us to advertise the loopback. So we'll do the same. IP OSPF1 area 79. That should put the loopback in there for router 9. And that will enable it on all the interfaces we need for router 9. So we should be good to go with 6 and 9. I don't think we've entered in 6's configuration yet. No, we have not. So let's do that now on router 6. Then we'll have the fun with router 7, and that's going to bring up all our adjacencies, right? So router OSPF1, network 150.1.6.6. Let's just look at our commands here. network, and then network number, and then wildcard bits area. We have to type the word area, and then of course this is going to be area 67. Not much to that. Network 155.1.67.0, area 67. Okay. Now the router in the middle, router 7. For him, what we need to do is, like router 6, we're going to use the router configuration mode, router OSPF 1, and he is going to be in both areas. So which interfaces does it want us to use? All right, 67 and 79. So this should be pretty obvious, right? Network 155.1.67.0. And this is router 7, not router 6. And he will be in area 67 and network 155.1.79.0 in area 79. So he's going to be in both areas. He's going to play both fields. Okay, boom. Now we should see adjacencies come up. Loading to full, done. That was quick. So he's formed an adjacency with router 7 or 9. Now he has with router 6. Okay. Now notice we did not change, we have not changed the network type. I'm assuming that is going to be shown as a broadcast. That characteristic or that attribute should be derived. All right, there's some commands that I want to get more familiar with here. So router 7, well actually let's verify that this worked first. On router 7, both loopbacks should be reachable. So 150.1.6.6, yep. Okay. We're routing OSPF, people. Pat on back, self-administered. First OSPF lab in a while, and went smoothly so far. Now let's try to get familiar with, more familiar with some of these validation commands and look at them in depth, because we're going to use these a lot, right? So one of them is show IP OSPF. Here we have a lot of options. I can put the process ID number. For example, on router 7, I'm running 2 different processes. So I can do show IP OSPF. If I use it without specifying a process, it shows me both, right? Actually, this is still a single process. This is still a single process. So this would be like a area border router, right? But there's no communication between area 67 and area 79 because we have no common area. We have no area 0, right? But we're still running a single routing process, and router 7 is in 2 different areas. So he's basically like a border router. We'll see that in a second. We'll see what the LSAs look like. That'll really tell us. Okay, so what do we see here? The start time, time elapsed, sports opaque LSA. We're not doing that. Link local signaling, sports area transit capability, which is what we're doing. Well, not really. We're not really a transit area. I don't think. We'll see. Initial SPF schedule delay. So there's a lot of stuff here. I'm not going to try to absorb all of this today in this first lab. Again, I'm just kind of getting familiar with what I can see here. And it's showing me both areas. Number of interfaces in this area. No authentication. When SPF algorithm last executed and how many times. Area ranges are number of LSA 3. So there are 3 LSAs. I think that's what that means. Number of interfaces in this area 1. Okay. Show IP OSPF interface. And we can do a specific interface, right? We can do brief. That's interesting. I don't think I've used that. Maybe I have, but not in a while. So the brief shows us the interface number, process ID, area number, the IP address and mask, the cost, and the state. Backup designated router. Now, would it show me that on, I'm trying to think, on a broadcast network or broadcast interface? Yes, it would. You have to, on a broadcast network segment, you have to identify a designated router and a backup designated router. That's right. On a point-to-point link, you do not, but we have not specified point-to-point in this case, right? Even though it is a point-to-point. All OSPF knows is this is a Ethernet broadcast interface. So let's do show IP OSPF interface, GI0167. Yeah, and here we get more details, of course. The cost, topology name, base, and network type broadcast. So that is the derived network type here. Transmit delay is 1 second state BDR, priority 1. And it will also show you in this command who the designated router is and where he can be found, right? Your time intervals, retransmits. So a lot of good info here. Last flood scan length, neighbor count, and adjacency with this designated router. Okay, good stuff. The other thing we'll be using a lot is debug IP OSPF, and in particular, like adjacency. So we'll leave that on. We're not going to see much right now, but we might in the next lab. And then, of course, the big one, show IP OSPF database. So we're going to spend a lot of time in here, right? Okay, we do have just 2 LSA types. So he's not really an ABR, right? So in the database, which they should all agree on, right? So if I go over to router 9, oh, actually, that needs to be router 10, doesn't it? Router 9, show IP OSPF database. They're all going to agree in this area. So if we look at 7 and 9, for area 79, how many LSAs do we have? We have router link states 2, which is what we would expect. And there are 2 links from router 9, which we configured. And then we have one network, one LSA type 2. Right. And the reason we have is because, I'm trying to think why we have a network LSA here. This is router 7. Okay. Okay, that is because let's see, on router 7 we enabled this on 2 links. but only one link in area 79. In router 9, we enable it on 2 links. So this is the router, and this is the link that we added, right? The link ID 155.1.79.9. We don't, however, have one for, yeah, I'm not sure in this case. Because he only has a single link here. And router 9 has 2 links. Okay. One is the router itself. The other is the network. So router 9 we did, okay, that is the link ID. This is the loopback. That happens to be the router ID. No, that's not a route to the loopback though. Yeah, I guess I'm not sure why I'm seeing show IP OSPF database. Let's do it by area. We can do that, right? No. Process ID 1. OSPF router with ID. And we have 2 LSA type 1s, which are router IDs. Saying this is this router 7.7, and this is this router 9.9. This is my neighbor. Network link states, okay, I understand. The reason is because both router 7 and router 9 are advertising this network, right? And to get to it, I have to go through router 9. Router 9 is the designated router. So if I'm on router 7 and I need to get to this network, I would go through router 9 because he is a designated router. What I don't see in here though is a link that we enabled for loopback 0. Let me make sure I did that right. Show IP OSPF interface. Let's do summary. Brief, sorry. Yeah. Loopback 0 is there. Oh, it's a state loop. So it has to know the link type, right? So the link type is a loop. So that must be why it's not advertising that as a LSA type 2. Although let's look at router 7. Show IP route. Yeah, intra area. So my question is, show IP OSPF database. Yeah, I do not see a network. I don't see an LSA type 2 or the loopback. I guess I would expect to see that here. Unless somehow it is adding this link ID. Okay. It looks like it is. So here's a question. What if on router 9, I change the loopback address? IP address 1.1.1.1. Okay. So first of all, how does that impact the router ID? It's going to be derived, right? So let's change that. Router OSPF. Okay. So now I want to have a different router ID than my loopback 0 address, because right now it's probably set to my new loopback address. Show IP OSPF database. It has probably not reset it. Clear IP OSPF process. Yes. All right. Now we got this. I think we're running debug here. Synchronized. Look at that. We see the election, neighbor change event. Now, the designated router ID is still 150.1.9.9. Interesting. Show IP OSPF neighbor. 150.1.7.7. Show IP OSPF neighbor. All right, so even though I changed the loopback address, my router ID stayed 150.1.9.9. Now, how does it, where is that configured now? Show run. Okay, interface loopback 0, IP address, okay. IP OSPF1, area 79. And then the other interface, IP OSPF1, area 79. Do I need to clear that here as well? Clear IP OSPF process. Yes. And on router 7, okay. Now it's showing the neighbor. So we had to clear it. And now show IP OSPF neighbor. Interesting. So this is a little buggy, I think, because what's happening, we'd probably have to clear them both out. Let's do that. Clear IP OSPF. Well, let's just take the configuration off. Show run. Yeah, let's just take it off and then put it back. Yeah. No router OSPF1. And a router 9. Actually, let's go back to router 7. Flush. Yeah, it's doing all kind of stuff. Undebug. Back to router 9. And interface loop 0. we want this? No, on both these interfaces. That should clear the OSPF process on both these routers. Show IP protocol. Yep, it's dead. This one is not dead yet. Clear IP OSPF 1 process. Still there. Why are you still there? Because you're stuck, probably. Probably gonna have to reload this router. Yeah, he's not there. Oh, router OSPF once. I don't remember typing that. Okay. Okay, now it's dead. All right, so let's start over. This time, to router OSPF 1. Router, let's change the interface back. IP address 150.1.9.9. And this time, I'm going to say router ID 1.1.1.1. And we're going to put all the configuration back. Then I want to see what the database looks like. So let's go to router 7. And back to router 9. Oops. Okay. So we're going way above and beyond what the lab called for, but gotta understand this, these LSAs. It's all about the LSAs, right? And this is the most basic lab. We should know what our OSPF database looks like here. So our needs a little time for convergence. Show IP OSPF neighbor. We can look at the state here, right? It's two-way, so it's still working. Xstart, okay. BDR. Full. That took a little time, but it's full now. So show, let's look at router 9, be easier there. Show IP OSPF database. Okay, so it basically looks the same. We have our router LSAs, type 1s for Area 79. There's a router ID, which can be, that's just a 32-bit number, right? I just happen to use an IP address. The link ID is this. Then we have router 7. Then we have this network here. So my question is, if I look at the tree, the OSPF tree, right? I should see a network for, let's see, okay, let's confirm I have reachability. Ping 150.1.9.9. I do. Show IP route 50.1.9.9. Okay. known via OSPF 1, last update via this interface. But how do I know that from the OSPF database? Because I don't see anywhere a reference to 150.1.9.9. I should see a network state here. So what I'm going to do is I may throw this out to the group. I may throw this out to my study group. Why don't I see this network? Because that would be intra area. Yeah, I'm a little confused by that, but let me check the key, see if there's any information there I might be missing. Yeah, router. Okay, looks right. Yes. All right, so let's look at this command here. Show IP OSPF interface GI0179. Interesting. Attached via interface enable. The reason for that here is because this is a sub interface. So it has derived that, and it's going to say network type broadcast, right, by default. Show IP OSPF neighbor, we did that. Although adjacents have been established. Yeah, backbone area 0 is not configured. That's probably why we're having an issue. Well, that's why we cannot route between areas. Yeah, I don't get it. How does router 7 know about 150.0 or 150.1.9.9? How does it know how to get there? For example, I could create another interface here, interface L1, IP address 2.2.2.2, 255.255.255.255. Right now, router 7 should not be able to get to it. Right, he cannot. But if I go over here and I say interface L1, IP OSPF, what is it, area or process ID first? 1 area 79. Now I should be able to get to it. And I can. But is it in the database? I sure as heck don't see it there. Show IP route 2.2.2.2. Okay. All right, we're gonna have to move on and just research that. My key doesn't say anything about it. So let's go over to the next one. We did get basic routing to work, so yay to us. golf clap. Now we're going to do the next lab, which is non-broadcast network. So let's reload router 9, because we've already done all kind of stuff to this guy. No, yes. Same with 7, 6, and reopen a window for router 10. Okay. Good deal. So on this one, let's take a look at this next lab. On the other one, when we did show IP OSPF interface, it sort of determined the type of interface and then knew that it was a broadcast link. So in that case, a DR and BDR had to be selected. In this case, we're going to do a non-broadcast network. So we're going to have to kind of tell the links what they need, what type of link they are and how they need to behave. And in this case, whenever we do a non-broadcast, let's see, I'm not sure. I don't think we have to define network statements here, because this actually will, when we say broadcast, we're talking about supporting multicast address, right? So the neighbors can discover each other without having to use a neighbor statement. I believe with the DMVPN, as long as we define it as a point to multipoint, then we still will not need to define the neighbors. It's still going to be let's see, over DMVPN, it's still going to be broadcast, right? The neighbor's going to still be able to auto-discover. We just had to define it as a point to multipoint network. And we'll explore a little bit how that changes the behavior, right? So on our requirements, router 1 through 5, which is this DMVPN cloud here, 1, 2, 3, 4, 5. We're going to configure the tunnel interfaces. We're going to use a GRE tunnel. And we're going to advertise loopback prefixes into area 0 for routers 1 and 2. But we are going to have also, and we're going to assume area 0 on router 5, the hub. So basically all routers will be in area 0 through the tunnel network. But the loopbacks we're going to do a little different. So routers 1 and 2, their loopbacks will be in area 0. And then we're going to have routers 3 and 4, there'll be an area for each of those for their loopbacks. So this is going to get kind of interesting here. Router 5 is telling us we have to use a single network command. See, he's not going to advertise any loopbacks. Routers 1 through 4 also, they want us to use interface level only commands. And change the OSPF network type to non-broadcast. Okay. Interesting. On routers 1 through 4. Very interesting. All right. Well, let's go ahead and get our configuration tool out here. We're just going to use Notepad for now. And we're going to say router 1, router 2, router 3, router 4, router 5. All right. So routers 1 through 4 use interface level commands only. So these are going to be interface tunnel 0. And we're going to say IP OSPF 1 area 0, right, on all these. Okay. Routers 1 and 2 are going to advertise there's loopback 0 prefixes into area 0. So We're also going to do interface L0, same. Interface L0, same. Router 3 is going to have, he likes to be a rebel. He just wants to be different. So we're going to do interface loopback 0, IP OSPF 1, same process ID, but this will be area 3 for router 3 and area 4 for router 4. You change the OSPF network type to non-broadcast. Now this is for all. So before we do that, let's look at the command reference again. We were just there. IP OSPF network. Yeah. So it said to change this to non-broadcast, right? Set the network type to non-broadcast multi-access. Now I think if I do this, yeah, if we do non-broadcast, the neighbor command is required. Right. So it looks like on any of these, and that makes sense, right? Because if you do non-broadcast, that means we're not doing multicast. And so we cannot have automatic neighbor discovery. So we're going to have to use the neighbor statement. Okay, so let's look at the neighbor statement here. And I'm not sure if it's just IP OSPF neighbor. No. Let's find it. Let's go with the master index. I want OSPF. So I may have to get a little sneaky here. And instead of the master index, let's go to the command reference for OSPF. Let's see how well this works. 15.6. Instead of master index, command reference, IP routing OSPF command reference. Okay, and then the index. Neighbor OSPF. See, if we would have gone to neighbor in the master index, no telling where we would have gotten. But here we go. Use the neighbor command in router address family topology or router configuration mode. So it almost looks like the neighbor command is going to have to be used. Our requirement here was that for routers 1 through 4 that we use only interface level commands. But we want to change the OSPF network type to non-broadcast. If we do that, we have to add a neighbor. Router address family topology configuration, router configuration. Okay. I'm wondering though, yeah, you cannot use neighbor, excuse me, on a non-broadcast network within an OSPF virtual private network routing instance. Okay, I think we have to do point to multi-point, non-broadcast. All right, let's just see. We could also do in the command reference. The configuration guide. Let's take a look at that. I think we're going to need the help. We can't just use. Sometimes it's important to recognize, I think, when just looking at the command reference And if that's still not working, you got to back out and come into the configuration guide. So I think I saw a configuration guide on DMVPN. DMVPN, maybe not. Configuring OSPF. Configuration examples. What happened there? Okay. So here we have OSPF point to multipoint. Point to multipoint with broadcast and point to multipoint with non-broadcast. This is essentially our DMVPN. Okay, looks like we're gonna have to do the neighbor commands. I don't see anything here for DMVPN. So let's just use this guide, and we'll keep that handy. All right, so it looks like let's go ahead and configure these basics first. I at least know this part is right. Router 1. And then, let's see, according to the configuration guide, we're going to need to say here IP OSPF network type. Okay, here are options. Broadcast, non-broadcast, point to multipoint, point to point. I think we need point to multipoint, non-broadcast. I'm on the interface level, right? Invalid type for interface, loopback 0. Yeah, we have to do this on the interface tunnel 0. Okay, like that. Okay. So what was that command? IP OSPF network point to multipoint, non-broadcast. Okay. So I'm going to do that here. Okay. Router 5. Our requirements. Use a single network command. And it does not limit us here to interface level commands. So we're going to do on router 5, router OSPF 1, area 0, and interface tunnel 0. Going to do that command. Also, process ID 1, right? Use a single network command. So here we want to do all the loopbacks. Well, we want tunnel interface to participate. We're just defining, not what routes we're going to use. We're defining which interfaces should participate in the OSPF process. And that's our tunnel 0 address. Show IP interface brief. Tunnel 0. Okay, 155.1.0.5. So network 155.1.0.5, area 0. Yeah. Router OSPF 1, network statement. Interface tunnel 0, IP OSPF network point-to-point point-to-multipoint non-broadcast. Okay. I think that is our config. So let's apply it. See what happens. Router 2. Router 3. Router 4. Actually, 3 I may have done. I needed to do that different, didn't I? Yeah, router 3 is loopback. Interface L0 is IP OSPF 1 area 3. And router 4 is area 4, right? Okay, router 5. Okay, let's see what we get in terms of adjacencies here. Show IP OSPF. Show IP OSPF interface. Okay. Point to multipoint. Attach via network statement, right? Network type. We have no neighbors, so do we? Yeah. So we do need the neighbor statement, it appears. Router OSPF 1, neighbor. 155.1.0.1. Neighbor 5.1.0.2, 3, 4. And I think we have to do the same here, right? Router OSPF 1. Can we do this interface level? I don't think so. IP OSPF. Or will it just form an adjacency? I saw a message. Okay. Process. Okay, good. Yeah, that's right. We only need it on router 5. Cool. Nice. Show IP OSPF neighbor. Cool. Okay, so this acts like point-to-point, right? Essentially, one link to another. There is no DR or BDR on these interfaces. Good deal. So now let's do show IP OSPF database. All right, this should be interesting. So this should be the shared database between all, this area 0. Okay, these should all agree. Yeah, except for the age will be different, right? And then we have, okay, we have these network link states. So now, why is it that I have area 0? Yeah, I'm not understanding this network. Because I should have reachability to all the loopbacks. I do not. Yeah, something doesn't look right there. Show IP OSPF interface. Let's do summary. Brief. Oh, this is down. Interesting. Cost 1 state is down. He is in area 0, participating in OSPF. Neighbors, yeah. Okay, I need to take a look here and see. Okay, this will change it. Interface tunnel 0. Okay. So when it said change it to non-broadcast, it meant literally use the command non-broadcast instead of. We got too fancy here. I guess the point to multipoint is probably applicable in frame relay because you have to map. You're going to have virtual circuits. And they're going to act like a point-to-point. Each virtual circuit will act like a point-to-point link. And that's why you need a neighbor statement. All right, so basically it's saying IP OSPF network non-broadcast is what it should say. And then we need the priority command, right? IP OSPF priority 0. Okay. So let's go back. Router 2, interface tunnel 0, IP OSPF network non-broadcast. Obviously, I need to study this some more. OSPF priority 0. Router 3, IP OSPF network non-broadcast. IP OSPF priority 0. Send router 4. Network non-broadcast. We looked at these. IP OSPF priority 0. Hardly say it. And then the difference here, router 5. Oh, because what router 5 is going to act as the hub. So router 5 needs to. I'm not sure why they're doing this. Interface tunnel IP OSPF network non-broadcast. Oh, we need to take out the neighbor statements. Show run. Yeah, and we need to take all these out. Router OSPF1. Neighbor deconfigured. Show run. Okay, so we've changed the type. Router OSPF1, we need to put. No, we do need the neighbors. but just on the one side. Okay. So let's see if we get our adjacencies back. X start. Okay. So again, in the case, it looks like it's stuck. Attempt DR other. Interesting. Debug IP OSPF adjacency. Okay. I was just being impatient. It's having an issue with somebody. 4, did we not configure 4 properly? Show run interface tunnel 0. No, he just took longer. He's the slow one. He rides a short bus to school. Router 4 does. Okay. Okay, I'm just looking at my key here to see. All right, we still have some DR BDR election going on. Undebug all. Okay, so show IP OSPF interface brief. So it is enabled, area 0. Show IP OSPF interface brief. It's also enabled. Tunnel 0, it says state DR other. And it says DR. Thought though we put the priority. Interesting. Okay. Now, does that mean show IP OSPF interface brief, DR other, DR other, okay, DR other, DR. Yeah, see, these are supposed to be, these should be BDRs. These should be BDRs. Because we set a priority 0. Okay, I'm not going to worry about that too much. The main thing is that they are not considering themselves a DR. Which are not. Really, in this case, router 5 is a hub. Nobody else can be a designated router, right? On this multi-point, on this DMVPN. Yeah, the default network type on a DMVPN interface, which is GRE, is point-to-point. That's what it would show before we changed it. Which I could see why that would be an issue, because it would issue it's not point-to-point, it's point-to-multipoint, right? So therefore, we change it to non-broadcast. Hello's exchange is unicast with the neighbor statement. It is only required on the DR. So basically, that's why we needed the command here. Show run interface tunnel 0. Yeah, that's why we need the command here, because we don't ever want him to be a BDR. We only want router 5, and that negotiation is over. We make IP OSPF priority 0. So router 5 is only ever the BDR, these point-to-multipoint links. Okay, it says they will see themselves as either BDR or DR other, because they do not see each other's OSPF hello packets. Okay, that's what we want. And so now if we go to router 5 and we do show IP OSPF interface tunnel 0, non-broadcast as a network type, attached via network statement. And here are the adjacencies, right? It should also say, yeah, no backup router is designated on this network. Which is okay, that's what we want, right? Yeah. So once we have this adjacency, we should be able to see now the type 3 LSAs, the network summary. So using the show IP OSPF database, output on R5, the summary address should show IP OSPF database. Here we go. So this is the first time we're seeing this in these labs. But as we would expect, we have our router, our type 1s, with the link counts here. I'm not sure why this has link counts of 2. And then we have network link states, 155.105, summary network. So this is because we don't know the area. We don't care, right? All we see is that this is in another area, but that we reach these through area 0 on this router. But if we look over here at router 3, for example, show IP OSPF database, we have these other areas. From the perspective of area 0, it looks the same. From the perspective of area 3, these are also outside of our area, right? But these are essentially ABRs to area 3. Yeah. So router 5, show IP OSPF. Let's look at that again. Let's do summary. And I did not use this before, but link state age, area 0, summary, net link states, link state type, summary links, link state ID 15133, advertising router 15133. Network mask 32, metric 1, 4.4. Okay. So these are our, when I do show IP OSPF database router, that's cool. So I can actually tell it, just show me the type 1s or the type 2s, which would be network link states. Yeah. Address of a designated router. Right. That's how we get to it. And then summary. I have 2 summary networks. Okay. I'm going to have to do a lot of reading on this. We did get through the lab, but I can't explain everything right now. For example, my key questions that I'm going to have to research. One is the first lab for the loopbacks. Why are they not listed as LSA type 2s? And how does OSPF know? I keep transposing that. How does OSPF know how to get there via the SPF graph? Then in lab 2, when do we use broadcast, non-broadcast versus point to multi-point non-broadcast? What's the difference? Right? And how does the graph interpret the summary link types? Let's say type 3. Because I'm looking at this on router 5, I'm looking at this summary, and I guess I understand. This will probably become more apparent when we do more diverse, broader networks, but basically this link state ID is 151.3.3, and the advertising router is this, which I have a router LSA type, so I know how to get to it. But it is in another area, so that's why it is a summary. Okay, I got that part. What got me stuck here was the use of the non-broadcast from point to multi-point. Yeah, this point to multi-point part, because that's basically what this DMVPN is. But yeah. All right, well, I'm going to take a little break, and after this, I don't know, let's see, it's about 7 p.m. I don't know if I'll get another lab tonight in, because I need to spend some time really, processing and unpacking these 2 labs and understanding them before I move on to the next. However, hopefully tomorrow we'll have some more labs, and we are looking at some more on manipulating the DR-BDR process. DR-BDR election. And then maybe even a point-to-point type lab. So all good stuff, all basics. Appreciate you hanging out. If you enjoy the stream, please like this video or subscribe to the channel to see more, and we'll see you in the next one.